Math 113, Lesson 2.8 covers circles. And really this is a review to get us to where we need to be in order to better understand the ellipses in Chapter 10. So 2.8 will be covered on this next exam that we have. So I don't want you to think you are in the wrong place. All right, circles. I think we all know what a circle is. It would be a set of points that are equidistant from a center point. So every circle has a center and a radius. And we talk about our circles using formulas. So the standard form of a circle would be explained using this formula. Now in this equation, the ordered pair HK is the center. Now notice the equation has x minus h and y minus k, but the center is positive h and positive k. That's going to be important when we move forward. And r is the radius, not r squared, just r is the radius. So hopefully you've seen circles before, and this is not going to be completely new to you. If so, that's okay. That's why we're going over it, to make sure we all understand circles. So let's say we have a circle whose center is the origin, 0, 0, and the radius is 4. And I want us to write an equation of the circle. And it's going to need to be in that standard form there. All right, so if we write our equation, so our center is h and k, and then our radius is that 4. All right, so x minus the h value squared plus y minus the k value squared is equal to r squared. All right, and now we simplify what we see because we can. Anything you can simplify, we'll need to. Well, x minus 0 is just x squared. Y minus 0 is just y squared. And then 4 squared is 16. So this would be the equation of our circle. Okay, so if I said, let's graph it. Let's graph the circle. Now, if you have graph paper, that would definitely be the best thing. All right, our center is going to be the origin, and our radius is 4. So that means we're going to need to go 4 spaces in every direction. All right, so our center is 0, 0. From our center, we count 4 spaces. Now, you cannot count diagonally, but you can count 4 spaces to the right, 4 to the left, 4 up, and 4 down. And then do the best we can at drawing our circle. It might look like an egg or a football. But this would be our circle. Our center is 0, 0. And our radius is definitely 4. This ordered pair is 4, 0. And I could list all the ordered pairs that I touched. And there we go. That would be the graph of our circle. Now the center is not always the origin. So let's do one that does not have the center at the origin. Right, let's say that my center this time is -2, 3, and my radius is, let's say, 5. All right, so we're going to do two things. We're going to write our equation. Okay, that's what we're going to do first, if I can spell it. And we're going to make sure it's in standard form, that equation that I showed you up above. Okay, so we've got to write our equation in standard form first. So I'm going to identify this is H and K, that's my center, and my radius is R. So X minus H. H is -2, so X minus -2 plus Y minus 3 is equal to 5 squared. Now I said any simplifying you can do, you should. Well, minus negative should not stay there. Okay, that should become X plus 2. Nothing I can do with this Y minus 3. 5 squared is 25. So there's my equation in standard form. We leave it just like that. Now if I asked you to graph it, all right, so now we're going to graph this circle. All right, so our center is -2, +3. Alright, so let me pick another color, and let's put our center -2, +3 right here, blue. Alright, the order pair -2, 3 is our center. Right? Now our radius is 5. So I count 5 spaces in each direction. So 1, 2, 3, 4, 5 to the right would put me there. 1, 2, 3, 4, whoops. Let me put that there. 1, 2, 3, 4, 5 to the left would put me here. All right, 5 down. 3 would be on the axis. So I go 1, 2 more to go. And then 5 up. I don't have enough places marked. 1, 2, 3, 4, 5. So I'm going to run into my words a little bit there. 1, 2, 3, 4, 5. Okay, so then I draw my circle that goes through. Oh, not a very good circle. So my center is at -2, 3. Now my radius is 5. Now that diagonal line that I drew, I did not pick a point to get there. All right. These are the points that I use to form my circle because I can go 5 up, down, left, and right. I cannot count diagonally, even though I can draw that line and say it's 5. So there would be our circle. One last idea here for our circles would be, let's talk about the domain and the range. All right, our domain, remember those are our X values. So when looking at this graph, X values means left and right. So the farthest left I go on this graph would be right here, okay? This point right here, that one right there. That's the farthest left I can go on this circle. So that is an X value of what? All right, so 1, 2, 3, 4, 5, 6, 7. So an X value of -7. So we go from -7, and we're going to use a bracket because it is equal to -7. And then we go as far right on the graph as we can go. That would put me in line with this point right here. So if I count, where is that located? 1, 2, 3. That's an X value of 3. Whoops. So my domain is from -7 to 3. Those are the X values. Okay, the X values. When I do the range, I'm looking for the Y values, and that's going to be up and down. Okay, so the highest point on this graph, I'll do this one in green, would be this point up here. And so we have to decide where is that point located. And that's, if I just count the spaces, how far up is that? 1, 2, 3, 4, 5, 6, 7, 8 is how far that is up. So this would be the big number. The small number would be this one down here at the bottom. And so how many spaces below the x-axis is that? That is 2 spaces below, so that's -2 to 8. Small number first, then the large number. So my range would be from -2 to 8. And that's really all there is to do with circles. Now I could draw a circle and ask you to write the equation by looking at the circle, but you have to just point out the center and the radius, and you're able to plug it into your formula. All right, let me know if you've got any questions.